First Spin.
Welcome to First Spin, a show where I learn about the parallax propeller without any prior programming experience. Rather than do this on my own, I have enlisted the help of two awesome experts.
We were going to record the show live this week from Comic-Con, but Roy said no.
Roy said there was no parking.
There's 5 billion people in one place.
Heck yeah, we could have dressed up like a propeller.
So
that would have been super funny.
I thought we'd be able to convince him because he lives in San Diego. You know what?
Yeah.
And so that would have been fun. But I guess he's packing and all that, so he's
cosplay
distracted
with beanies on our heads,
with other stuff,
modules all over the place. Dude, I think it should be a thing, right?
What, Comic-Con?
Dressing up like a propeller for Comic-Con, no one would understand it. Would be like, we're microcontrollers, obviously.
Yeah. So, have you actually got a chance to start packing anything, Roy?
No, I'm still working.
Oh ho.
We haven't had an opportunity to talk about that on the show.
Yeah.
Yeah, well.
Our expert just got a little more experty.
Oh, yeah.
More experty.
Yeah.
Yeah.
I'm coining that word.
You've made it to the Mecca.
Yeah.
To the Mecca.
Have any of you listeners figured out where Roy's moving to yet?
Are we allowed to say? Roy, are you allowed to say?
I think we're allowed to say now.
Yeah.
Okay.
Yeah. By the time this airs, it'll be after... I'll be almost done working.
Oh, yeah, okay. So where are you headed? Mr. Roy? Mr. Roy Eltham?
Bellevue,
Washington. What's in Bellevue?
I don't know. What's in Bellevue?
I don't know. Houses?
Lots of really cool people working at a really cool company.
Yeah, like, gosh, I don't know. John Smith, right? Like,
John Smith.
You know, Jane Doe, right?
I think there's an Alan up there.
Oh.
He's not there yet.
Soon.
He'll be there in a few weeks.
He will be.
There is a Jerry there.
Yes, there's a Jerry.
Yeah.
There's a Ben.
Yeah.
There's Jeff.
There's a Jeff. Yeah, there's a
Tanya.
Yeah.
Mm-hmm.
So where is this? I mean, it's like Starbucks?
No.
Like
there's a Starbucks across the street 2 different ways.
In Washington, there's a Starbucks?
No. Organic farmers market?
I think there's one of those across the street on the other way that there isn't a Starbucks.
So what's this mysterious company?
Valve.
Woo! Congratulations.
So
this is the official First Spin. Congratulations for our super expert.
Yeah. So all you other podcasts.
Too bad we got dibs.
Yeah, I don't know if I'll get on Amp Hour. I don't know if Chris and Dave like me well enough.
Oh, they will.
But I don't care.
They will soon realize
Okay.
your magnificence.
I think Dave and Chris
King
and
Roy.
I have an understanding that they have to ask permission to borrow Roy.
Oh.
I don't know.
It's fine, Roy. If you want to go be on the Amp Hour, that's fine. But you will have to listen to those two guys go on for an hour.
I don't know what I would say. I'm not really, in that,
You'd be like,
type of guest.
You don't take apart your oscilloscope for fun?
or throw things on the ground.
I'm kind of still not very much of an expert in electronics or anything, like, people
Yeah.
in there.
But the non-experts going to Valve. Please. Please.
But I'm going there to do software. I might do hardware in the future.
Yeah, still. That's
One nice thing
pretty
about
hardcore.
there is if you feel like walking across the hallway and helping somebody do hardware, you can,
That's true.
which is kind of cool.
Or play pinball.
But, that's just...
I did play pinball there last Friday.
Yeah,
I've heard
Yeah,
that
he
Jerry
did.
brought a lot of her pinball machines there.
it's true.
So
It's true.
that's got to be fun.
Yep.
When we were interviewing Alan on our show Zombie Tech the other day, he was talking about the pinball machines.
Well, we could hear the pinball machines.
Yeah, they're running in the background.
Right.
But so, Addie, do you have any questions for us this week, or are you just gonna
we're gonna keep
gossip?
going. It's not gossip; it's the truth.
Welcome to Engineer Gossip Hour.
Ooh, now that could be a show. That would be very interesting. Did you hear? guys? About that microcontroller? Yeah?
So anyway, about
Okay, so today, first spin. We're actually doing a first spin. So today we are going to be talking about the easy to understand 2-axis joystick, available, of course, at our favorite company, Parallax. And it's pretty easy. It kind of reminds me of the 5-position switch. But I feel like it's a little more complicated to set up hardware-wise.
Functionally, it does something similar, but
Right?
how it works under the hood is completely different, and you had to
Right.
learn a trick there that is very useful.
Right. So, as always, let's just go through the hardware, if that's okay.
Okay.
All right, hardware. So
Pretty simple.
we've got we're again looking at learn.parallax.com, and in the basic wiring diagram for the propeller, we've got 2 pins on the top, well, pretty much on each of the corners. And
Yeah, some of them are doubled up just to make it easier for wiring and stuff.
right. And you're going to need 2 220 ohm resistors as well as 2.01 microfarad capacitors.
Mhm.
And if we scroll down a little bit more to the propeller quick start example, I did it on the Prop BOE. I love the Prop BOE. Please get one
Yeah.
if you haven't already. But yeah, it's kind of a cluster of wires. To
Didn't we
hook
get a
it up.
package from them, like a new BOE?
Yes,
Was what was in that box this week?
yes, and the heart sensor, which we'll go through
Oh,
at some point in
cool.
the future. Yeah,
Ooh, cool.
I'm excited about that, and I'll be the expert.
I don't know if I've
'Cause I don't
actually
know if you
seen
have it,
the official released Prop BOE yet. I've only seen all of the revisions leading up to it. 'Cause
Yeah, no,
I've seen all the
they've
prototypes.
changed a few things actually. I'm kind of partial to the old Prop BOE. Not gonna lie.
You like your old broken one?
Yeah,
Cool.
I do. Because I've gone through so many different modules with it. It's like it's a friend.
You know it's quirky.
nostalgic.
It's
Yeah.
quirky behavior.
Yep. So the pins, I guess I'm under the
So the
understanding
2-axis
they-
joystick is
Yeah.
2 10K potentiometers, so variable resistors,
Okay.
and it's hooked up to the joystick, one going one direction and one going the other direction for
Okay.
up, down, or right, left.
Okay.
And then it's all spring loaded, so it centers automatically,
Yep.
right?
Yep.
And so those are the part of the resistor portion of the RCTime, which is what we'll use to actually read these.
R
Okay.
for resistor.
And then C for capacitor. And you
Okay.
need the 0.01 microfarad capacitors in order to help you do the measurement of where the joystick is at. Use those in combination with the resistors.
Okay. An RCTime, for those who don't know, is an object, but it's based on, I guess, an electronic property?
Yeah, well,
that we exploit.
there is an object that sort of automates it for you,
Yeah.
but you still
Right.
need to understand the hardware when you're doing it.
Yep.
The basic
Yeah.
idea there is that you're turning a pin on your microcontroller, which charges up the capacitor, and then you turn the pin off, and you count how long it takes until the charge goes away. And of
Right.
course,
And
this is going to be a variable depending on where that variable resistor is set to in the joystick. If you're pushed one way, that capacitor is going to charge faster. If you're pushed the other way, it's going to drain slower. So,
Right. And you can actually do the inverse too. You can actually drain the capacitor and have the resistor charging it and measure how long it takes to charge it.
Okay, so we have a variable. We have
It
two.
goes either way.
So we have a variable. I'm gonna just say, let's just talk about the up-down position, right? There's a variable capacitor, 10K variable. Variable resistor in for that up-down direction.
Right.
And we have a capacitor, 0.01 microfarad capacitor connected to that. Now, if the joystick is pushed one direction, say up, and this is pure conjecture, okay? It pushed up, and it increases the resistance of that potentiometer, then
Mhm.
it's going to take longer for the capacitor to drain, right?
Right, because
Right.
it's going through a larger
a larger
resistor.
resistor. And if I push that joystick down, there will be less resistance, right? Because again, it's a potentiometer. And so the capacitor will drain more quickly. And that number, depending on the resistance, as determined by the joystick, will tell us which direction that joystick is in. Right? So let's say the range is 0 to, and actually in this joystick's case, 0 to 6,000, right?
Right. If you're using 0.01 microfarad capacitors,
You could swap out a different cap and it would be a completely different number.
Right. So say 0 is like down and then 6,000 is up. So on your serial terminal, you would see if you push the joystick up, it'd be 6,000. You push the joystick down, it'd say 0.
You're essentially, you want to define yourself some thresholds, right?
Yeah.
So you can detect if it's this far out of center in this direction, if it's this far out of center. That's the most basic way to approach it. But this is an analog thing. So, I mean, you could technically, not with too great a resolution, but determine how far in one direction it was, not just if it was only in that direction. And that's where it's very different from the 5-position switch you were playing with.
Right. Since the 5-position switch was just like a yes or no.
Off.
So
It's on off in each
Boolean.
direction. Yeah.
So on a game
Boolean,
controller, this is very
logic.
similar to the analog stick.
Right.
Okay.
And
So then-
they
you could-
work pretty
you
much
could
the
push
same.
it up a little bit and get a little bit of movement, or you could push it up a lot and get a lot of movement, depending on the.
And if you go back to the Toymakers videos, I actually used these to do some prototyping with a couple of servos, working on a pan tilt camera head, and I used 2 of these joysticks to run my my multiple axis camera control thing.
Were you able
Just
to
fun.
ramp with these?
With those,
Like,
yeah,
so if
I
you
could-
slightly touch it, would it go slower than?
yeah, you can do that.
Yep.
Oh, okay. So,
Because
okay.
you can tell how much they've pushed it by reading the value, right? The
Right.
RC time value.
Right. So, with that introduction to RC time, I think I explained it in a way that makes sense, right? Maybe.
Sort of. I mean,
Sort of. No.
Yeah, I mean, the basic idea is that you set up a I/O pin as an output and set it to high so that it'll output a voltage, and it's going to charge up the capacitor.
Mm-hmm.
And then you set the same I/O pin back to an input,
Mm-hmm.
and you time how long it takes for it to change state from being high to low. And it will, that's how long, that time is indicative of where in the sweep the joystick is at.
Okay.
And you do that for both the up, down, and the right, left, and you can get the exact position of the analog stick by using both of those values.
And if for some reason you need to use 2 different pins, you can do that too.
Okay.
Right.
And the joystick, it runs off of, was it 5 volts? Is that right? Maybe?
Well, it'll work off of 3
point-
volts also.
okay.
It'll work off of 3 or 5. It'll just take longer to charge the capacitor and,
Okay.
or
Anything
Different.
you're changing about the capacitance or the voltage or the resistance range is going to change your timings.
Right.
Right.
So, okay, so let me ask. I mean, this may be an irrelevant question, but I'm just curious. How long does it take to...
it's very
Well,
quick
Okay.
to charge up the capacitor because you're dealing with a very small capacitor.
Yeah.
So they charge in the particular RC time object that we're using, they let it charge for 1 millisecond.
Okay.
Which is more
And
than
then-
enough time for that thing to completely saturate. So
Okay.
Right.
Okay.
Even though it's only a really tiny amount of time for you, the electricity is charging up that tiny little capacitor really quickly.
Okay. So then the pin goes output, then input very quickly.
It goes output and set to high, and then waits for 1 millisecond, which is several clocks of the processor, right? And then
Yeah.
it gets set to an input and read until it goes low.
Okay. And do you know the voltage point? Like, is it half?
Well, it's the standard for whatever microcontroller you're using.
Oh,
So,
I see.
different microcontrollers will have different thresholds for when they switch.
Did we ever
from
talk about
high
the
to
threshold?
low. Yeah, we did
For-
way back in the beginning when we were talking about the propeller.
Okay. I'll have to re-listen.
Yeah.
Because I don't quite remember the exact threshold. I mean, I know the brownout threshold voltage, but that's slightly different. I mean, that's just turning the whole thing off.
Yeah.
And then we don't want to do that.
You can also just go look it up in the propeller datasheet.
Ah, I should do that. Okay, so let's go ahead and go through the code then. So we're still looking at learn.parallax.com's code. And so we have the objects. We have, obviously, the serial terminal with full duplex serial. We have the RCTime object. And that is, I believe, one that is in the prop tool folders, the
Right.
library folders.
And just so you know, you were right. It's approximately 1/2 the voltage
Was I?
for
Hex,
the
yeah.
propeller. So about
Woohoo.
1.6 volts.
Okay, very cool. So that's either for a 5-volt source or a 3.3 volt source.
Well, no, I'm just talking about for the propeller specifically.
Oh,
it's
I
1/2.
see.
For it to detect it as a high.
I see.
So
High
as soon
versus
as it
low.
drops below, he said, 1.6 volts?
Yeah.
That's when it's going to go 0. So there's plenty of formulas out there for calculating RC circuits and how
Mhm.
long they take to charge and how long they take to discharge.
Mm-hmm.
And, it charges very quickly because in this particular, there's 2 different ways to do this, but in this particular one, you're charging it straight
Mm-hmm.
and you're discharging it through a resistor.
Okay. I think, and this is quasi side note, I think it's interesting because, most potentiometers are like the side swipe, like they're a dial, like a knob, right? And it's a wiper going along a resistive strip. I think it's interesting that this is like an up-down. Is it like an up-down strip, I guess?
No, they're actually 2 little round things
Really?
on the sides.
One for each
If you-
axis.
Yep. And you're turning a dial with the
If
stick.
you look at the sides of the joystick,
Really?
you'll see the axles.
Oh, hot diggity.
I remember the first time I figured this out as a kid. I took apart my Commodore 64 joystick, and I saw that there was potentiometers in there. And then I was looking at the SID chip definitions, and it has 2 analog inputs on the SID chip, and those analog inputs get directly tied to those potentiometers in the joystick. And it was just like a light went off in my head, and I was like, "Huh."
You had a fancy joystick because I was using an old Atari joystick with my Commodore 64. So it was just switches.
That's very interesting. Well, you just learn something new every day.
That's
Okay.
what we're here for, Addie.
Thank you. I appreciate it. So then we have obviously our constant section, and then we have pub go with local variables UD and LR.
For
And
up, down, and left, right.
right. And then we start the serial terminal at 115.200. And just to let you guys know, so when I ran this, and I was using Parallax Serial Terminal because I had my PC backup, I noticed in the Parallax Serial Terminal that the baud rate was it started for me at 9600. And when I first turned on the prop and ran the program, it gave me all this random junk, like the stuff that you see coming out of your printer when it's testing a page.
You got to make sure your prop tool, your Parallax serial terminal program is set to the right baud rate.
Right.
As what
To
it's
match
set to in the
whatever
code.
is in the code. Yeah.
Right. And so I was like,
We've got
okay.
For.
Right. And I'm like, okay, wait a minute. I'm seeing junk. Gotta check the baud rate. Bam. So,
Yep.
I think we've all made that mistake before.
yeah.
Using the wrong baud rates on both sides.
Me
and then
more
you're
than
like,
once.
where's the bug? Where's the bug in my code? And eventually you look again, you're like, oh man, I'm
It's just
stupid.
the stinking baud rate.
My favorite is when you forget to set the direction of the pins. Or you
Yep.
set the directions of the pin
Oh,
in
yeah.
your main pub, but you're actually toggling them in a different
Yeah.
subroutine, so it can't actually, because you have to actually set the direction in the subroutine that's changing the pin.
Right.
Yep.
Yeah, that one's bit me a few times.
Not quite so expert there, eh?
Uh-oh. The expert is starting to
He's getting a
Do
little
some
bit
burns.
a little too big for this show, right?
No.
Okay, so then rc.rctime 01 @LR. So
The first parameter there is which pin. So the left
okay.
right variable is for pin 0.
Yeah.
And then that second
I see
parameter to RC time is saying that you want the pin to be charged up to high
Okay.
and then wait for it to get low. If you had made that a 0, what it would do is drain the capacitor and then it would wait for it to charge up and go high.
Oh. Okay.
And so it's you can do it the opposite way if you want to. Most people do it this way where you charge it high and let it go low, but
Right.
you could do it the other way if you need to for whatever thing
Whatever
you're
reason.
doing.
Okay.
And then of course it's passing the address of LR so that it can fill in LR with the value
Mm-hmm.
that it got from doing the RC time algorithm.
Okay.
And then
That's
the second one
interesting,
is
yeah.
the second one is the same thing just on pin 1 and for up down.
Okay. Got it.
Right.
Got it. And then you send a string to the serial terminal, string UD equals up down equals, and then send the decimal of UD, which was stored previously from RC time.
Right.
Same thing with LR. Then you send a return, and then you wait, half a second?
Yeah, they're set their thing up to just do a reading every half second.
Right.
You could go probably a little faster if you wanted to.
Right.
This is just a demonstration program to show what it does.
Right. And so one thing, so we mentioned just a little bit earlier that anything from source voltage to capacitors will change the readings. So if you have 0.01 microfarad capacitors, then the range will be, say, left to right or up to down, will be from 0 to 6,000, with your center being at 3,000.
Right.
Which is lovely, which is nice, but I
And
actually...
remember, we're talking analog here, so those numbers are not going to be exact.
Precise.
Right.
You'll usually when I build one of these things, I'll test it with my exact circuit that I'm using, and
then use the ranges based
have
on
a
that.
program that just prints out the numbers and move the joystick up and down the full range and right and left the full range. And usually I'll also let it warm up a little bit because that might have a slight effect on it. Be on for a minute or two, and do the same thing, and then record those ranges for the minimum and maximum and for the center,
right,
in like a little piece of data at the bottom of the program, and then just use those values.
Gotcha.
And this is why
That
you
makes
would
sense.
use thresholds, and why you would use, instead of going with the literal number, you define thresholds along the range,
Yeah.
so that
Right.
you've got wider
Tolerances.
snaps, like on a grid, right?
Yeah.
Right.
So
like for the center, you would
by using that, you could have the same code and put it on multiple devices and get the same result. By widening the snap, it becomes more and more the same across different different literal hardware.
Mm-hmm.
Right.
Gotcha. So my thing, I mean, and that's nice if you have 0.01 capacitors, but I haven't yet organized my capacitors from 0.000 whatever to 10,000 or whatever, and so I managed to find 1.01 and 1.02, and I was like, I'll just try it and see what happens, and from looking at this, I pushed at center, the up down number was 200.
It looks like you got a Mylar cap there. Does it say 102 on it?
It says 103.
103. So that's
0.01.
you gotta move it 3 decimal places.
Yeah, it's 0.01.
Okie dokie.
Yep. And I'm pretty sure. Yeah, this I don't know. I'll see. But I think this one's 0.01 and this one's 0.02. Anyway, and then the LR middle value seemed to be around 80. So totally not 3,000.
Well, it sounds like it wasn't 0.02, but maybe 0.1 instead of 0.01.
Yeah, that's what I was thinking.
Man,
I don't know of any.
I thought 103 was
0.02 does not sound like a value you can buy.
Yeah.
Oh, well, all right, maybe. So then, and then I did up and left.
So I asked about the 102 thing. If you were just seeing it as a
No,
you were,
I
you were thinking the 2 was a
I
digit
used my
instead of a place.
bifocals.
Uh,
I used my magnifying
But
glass to look
the other
at
thing
it.
to
I was
remember
pretty
is on
sure.
those capacitors when they're doing that 102, it's all in like picofarads instead of microfarads. So you have to like figure out the translation from picofarads to microfarads.
I'm making a face right now.
Capacitors are fun.
So
Well,
when it's
small and
like
readable,
when it's
illegible.
103, it's saying, 10 with the thing moved over 3, so it's 10,000 or maybe 100,000. I forget the exact. I always have to look that up still.
Yeah.
I'm not an expert in the electronics field yet. I'm
Well,
just
that's
a
fine.
moderate to novice.
That's fine. I just chose a
But-
bunch of small ones that looked small.
Yeah, and in
so-
this particular case, it doesn't matter too much with RC time. It'll work with pretty much any configuration.
Right.
You just limit the precision that you'll get because of your processor being able to time it or not.
Sure.
You can make it more precise or less precise depending
Sure.
on your setup.
Sure.
If you were clever, you could actually have your code look for what's the maximum range I've seen, what's the minimum range I've seen, and then scale
Mhm.
its snaps accordingly. So eventually they're going to push the stick all the way up, all the way down, all the way left, all the way right,
Mhm.
and then it'll have a really accurate thing specifically for those. It would take a couple of swings around for it to calibrate, but it could be self-calibrating.
Sure.
Yeah.
Yeah, so then my ranges just ended up for up down being 0 to 500 with a center of around 225 and the left right being 0 to 180, center of 80. I mean pretty easy to measure. But so for those who are like, okay, why are there a whole bunch of zeros at center? Probably because your capacitors aren't the right ones, cuz that's what I realized. Mine were like 4 microfarads. I guess that's a little too much.
Yeah. If you get the really big capacitors, they take a really long time, and then you'll have to.
And that's much
your
less
timing will
useful.
be- yeah.
Right.
You want a small capacitor so that you can read it really quickly and
Scan
get more
faster.
get more samples per second of where the stick is at.
Right.
That's like usually the goal is something
Right.
small so to go fast.
Right. And I also thought it was weird that I didn't have to hook it to the voltage line, like the VCC
Right,
or
because
VDD.
because you're
pin is
providing the
charging
voltage with the IO pin.
Oh,
So when you set the IO
guess that
pin
makes
high,
sense.
it's outputting a voltage, and that's what's charging the capacitor.
so it's actually a pretty passive process. Like the joystick itself isn't really doing anything except for moving 2 resistors.
Hmm.
Oh,
Mhm.
It's a very clever little solution.
I see.
One of these days I want to do, which is something that's kind of the opposite, which is to use the I/O pins, switch them between inputs and outputs to switch capacitors in and out of an LC circuit to have different tunings for the LC circuit by selecting different capacitor values on different I/O pins.
You could do that.
Yeah, and that's getting into weird mojo stuff, but yeah.
Cool.
Yeah, advanced circuits.
So that is my experience, my foray into the Parallax 2-axis joystick.
Yeah. Well,
And
the main thing to take away from that is that RC time is actually pretty useful. You could use that for lots of other things to measure analog signals.
Yep.
What else have you guys used RCTime for?
One thing that I use it for pretty frequently would be those little light things that change resistance, cadmium cells.
Mhm.
Yeah, I've used it for that.
Mhm.
Those are variable resistors effectively.
Oh, you know what I used it for? The cadmium cells. I used it for my heart project. Where you get
Right.
closer to the heart and the
yeah,
heartbeat
yeah.
gets faster.
So another thing you can do is if you use a really small capacitor so that it'll charge really fast, you can actually do a really slow, not very precise analog to digital converter of, say, an audio signal or some other signal, because you can use the opposite way. Instead of charging the capacitor, you can drain the capacitor and then wait for it to go high, and keep track of it going high and how long it took, and just do multiple samples, and you can read the voltage level,
Right. That makes sense.
at different time periods and create a wave shape.
Cool.
I've done that before to create a really simple, crude mechanism of sampling. It doesn't work too great. There's actually other better methods of doing that we might get into in a future episode.
Cool.
Well, we definitely don't have any time to do it in this episode because that's it for this week.
Yep.
You guys can find this show every week at firstspin.tv. We put it up on Tuesdays. Set up your phone to auto-download it. You can listen to it on the way to work Wednesday morning.
Mm-hmm.
Yep. Well, that's it for us for this week. We'll see you guys next week.
Bye.
Bye.
Later.